start with defining what we want to do. So first, what our task is. So we want a counter which counts button presses, right? Now which counts number of button presses. So we are gonna use button for it. We are gonna use display to show the output, and we will also have all of this will be run on a microcontroller, and I will use Atmega 328. Alright, so I don't have N here. So how do we connect it? Well, first the display, I will use the Peter Fleury LCD library, so I will do the wiring according to his example. The button will be simple connected with pull-up resistor. I'll use the internal pull-up in the microcontroller, and then my button will be connected towards the ground like that. And this is inside my microcontroller, and I will connect it to pin PC5. Right? So what the program is going to do. When I press this button, I want a counter to increase. So the counter will start like 0. I press it once, it will be 1. I press it twice, it will be 2, 3, so on. So if I look at the signal that comes out of the button, when it's pressed, when it's not pressed, the signal is high, right? So we have high here. When I press it, it will go to the ground. When I release it, it will go back to the up. Press it. When I keep pressed, it will be pressed, and then I release it. It will be like that. So here, I want to show 1. So I want this system to start with 0. Here, when the button is pressed, I want to show 1. Here the button will be released, so nothing happens, and here I want to show on the display 2. Here the button is released, so nothing happens. If I press it again here, I want to update the display to show 3 here at the moment. Alright, so now we know what the system is supposed to do, so let's design it. Okay, so first try, what we can do is that we can model this system using a simple one-state machine. So we will have our one state. I'll first write down the name, and the state will be that the machine is ready for key press. So I'll have my state ready for key press. And it's a state, so I'll put it in an ellipse. It's an initial state, so I'll mark it like an initial state. And what happens when I go inside? So the effect here on the initial state, on the transition into the initial state, will be set the counter to 0. Set the counter, so I'll mark it as a sign operator, so counter is 0, right? And I want to update the display, so update display. Okay, so now we have the state. So when the button is pressed, we want to increase the counter. That's the function of the device. So I will add one transition. The condition on the transition will be that the button has been pressed. Button pressed. And what I want to do, I want to increase the counter, so I would do ++ counter. Right, so this system in theory should, after initialization, should be reset to 0, and then with each key press it should increase the counter. Right, so this sounds like a reasonable system, so let's program this system here. I'll switch here into Windows. Okay. So this is Atmel Studio, so I'll start new project. I will call it button counter. And G executable project. I'll select my microcontroller 328. Now I have the P version, so I'll select that. Okay, I'll wait for a new project. I already prepared the library with the display, so that we don't have to wait for it. So I'll just delete the default main file and include my template. So I have it. Where is it? So these are my three files. So in the main C, what am I doing here? In the main C, I'm including the lcd.h. Then I have my glue function and setting up the stream, and then in the main I'm initializing this the display, setting up the stream, and printing hello world. So before I've configured the lcd.h, so it reflects my wiring. So I have my display connected to port D. I'm using the first 4 bits for data, and then I'm using the next 3 bits for the control signals. So let's see if the project builds. Let's test if I include it correctly. FCPU is not defined. Okay. So I will go to the project setting and define FCPU. It's important to have the timing correct, and we have to tell. So where do I do that? I go to toolchain, then I go to for C compiler. Where is it? Preprocessor symbols, and I will define the FCPU symbol here. So FCPU is F_CPU, and it's 1 million. 1, 2, 3, 1, 2, 3. Okay, I'll save it. I'll clean the solution and try to build it again to see. Okay, so the warning is gone, so my timing is correct now. Alright, I will try to upload it into my microcontroller and see if the display works. Whenever we are programming something, we should go through little steps like this to verify that it's correct. Okay, so I'll go to project settings, set up the tool, ISP. I have it in my debug wire, so I'll just use debug wire to program it and see if it works. So I programmed the hello world example, and it worked perfectly, so that's good. We are set up and we can continue working. Alright, so I verified that that my LCD setup is okay. So now let's define some helper functions to access the button. So first, the button is connected to port C, to port C5. So define some macros. button. We have button DDR is DDRC. We have button port, that's port C, and we have button pin, that's pin C, and we have button mask, and as 1 shifted to the left by 5 because we have it connected to pin 5. So now some functions. So first I want to initialize it as an input and set up the pull-up resistor. So here I'll go button DDRD, and I will initialize it as input, so I have to clear it. Button, and I'll use my mask. And here it was supposed to be pin. Alright. And I want to enable the pull-up resistor, so it will be button port, and I would just OR it with button mask. Alright. Now I want to check if the button was pressed, so I'll have my so I'll define a new function that would check if the button has been pressed, or not it has been, but if it is pressed. This button will return the actual condition of the button. So when the button is pressed, because it has a pull-up resistor. So if the button is pressed, then the input pin is in the state low. So we will return. We have to invert it because it has negative logic, and we will read the input from the pin register, and we have to read it. We have to end it or mask it with the button mask. Okay, so this function should return true if the button is pressed. So these are functions for reading the button. Now I will also want to update the display. So I'll have a function that would print the output to the display. So update display. This function would take the number of key presses. So I would have a press count, and it would just clear the display, and then it would print number of key presses. Printf. So I would just print it like this as count. Press count. Okay, so those are my helping functions. Now I'm going to design a state machine. So for a state machine, we have to specify the names of the state. A good construction how to do this in C is to use the enumeration type. So I'll define a new type of enumeration. Type def to define a type, and it will be enum, like enumeration, and the name of the type will be state t. Everything that ends with _t means that it is type. And I would have state, and the name of the state, I'll have a look again, was ready for key press. So I will name it like that, ready for key press. Okay, so I defined a new type for the state variable. Okay, Now, in my main loop, I will get rid of the printing the hello, and I'll start implementing my state machine. So first we need a variable to hold the state. I already defined the type of this variable, so this variable will be state t, and it will be state. Here I can specify the initial state, and the initial state is just wait for key press. We don't have any other state right now. Also, if I look back at my diagram, the initial condition is that the counter is 0 and we want to update the display with the 0. So I will create another variable that holds the counter. So I will have a press counter, and initially it's supposed to be 0, and also I want to update the display with this 0, so I'll call the update function, update display function. I'll have my press counter. Okay. And these are the initial actions. Okay, now in my loop, what I would want to do, I want to implement the state machine in the loop. So the machine can be in different states. We have states saved in variable state. In C, I can conveniently use the switch statement to decide whatever I want to do based on the value of the state variable. Okay. So I'll define what happens here. Break. So right now we have just one state. So how switch statement works? It looks whatever is in the variable state, finds it as an individual case here, and executes the block that that is under the appropriate state here. So if in the variable state is saved state ready for key press, it will execute this block here. If we had another state here, another case, it would execute the appropriate block based on the value stored in the state variable. So what do I want to do in this state? Whenever I'm in this state, I can have a look at this again. Whenever I'm in this state, I want to wait until the button, I want to not wait, but if the button is pressed, I want to transition in the state ready for key press. I want to increase the counter. So this is a loop, so the system will keep executing this machine, and that means that it will keep evaluating these conditions here. So here I can implement the condition of the transition. So if my button is pressed, I want to increase the counter. Well, I want to first transition into the state. I want to transition into state ready for key press, nothing changes. I want to increase the counter, so I'll go press counter plus plus, and I want to also update the display like that. So this here is my transition. Right. So this here implements what happens in one state, and this is the one transition I have there. Okay, what I forgot? I forgot to initialize the button. Show initialize display. Initialize the button. So I'll have a button in it. Okay, so let's try to build it, see if I have some typos in my code. No, it looks good. So what if I try to... So initially I have the count set to 0. So now if I press the button... Oi! so it doesn't behave the way I want it. If I keep the button pressed, you can see there how it's flickering. You just keep increasing the number all the time. Okay. So we have to change the state machine because this does not do what we want it for it to do. So we verified this program and it does not do what we wanted. So let's go back to the state machine diagram and change it. So here is the state machine we used. We just implemented, and this state machine didn't quite work. So what happened there? So when I pressed the button, it increased the counter, went back to the ready for key press, and then it evaluated this condition again right away and increased the counter again. Then if I keep the button pressed, it will just keep cycling on this transition. So in order to improve or fix this, I should probably be checking the key release as well. So whenever I release the key, I want to what I want to do is that I want to wait for the user to release the key and then go back to the ready for key press state. So how do I do it? How can I do this in a state machine? So I will enhance this state machine here. I'll just copy it, make a new copy here. So how to fix this state machine? So when the button is pressed, so we said that we have to wait for the key release. So we will add another state that's waiting for key release. Waiting for key release. Alright. It's a state, so I'll put it in an ellipse. Now, how do we get their state? So whenever the key is pressed, so key is pressed, or button, I call it button, right? So it will be button pressed. I would go to the waiting for key release state, and I would increase the timer, so increase the counter, so it will plus counter. Alright. Now, when I'm in this state, I'm waiting for key release. So if the key is released, I would go back to the ready for key press. So I would have the condition here, button released. Right, and one more thing I have to do here is update the display. Update the display. So this state machine looks good. Now, when I press the button and I keep it pressed, it should not add another key presses here, because it will be waiting for the button to be released. Alright, so let's implement this machine. We can continue improving this program here. So we have a new state. So it's state, and this state will be called well, how did we call it here? Waiting for key release. So this state will be state waiting for release. We have to add another case in our switch statement. So we will case waiting for key release, open a new block, and we have to close it by break. Okay, so now let's update the state for key press. So now we don't have a local transition, we have a transition. I'll delete this comment here. So when the button is pressed, we want to change the state to waiting for key release. So I will change the state to waiting for key release. We want to update the counter and want to update the display as well. Okay, so the system will do this state, go out, go inside, and now it will be in the state waiting for release. So if we are in this state, the condition there was that if the key is not pressed, we will go back to the initial state. So if button not pressed, and we will go back to the initial state. State waiting for state waiting for key press, and that's it. So this is our improved state machine. We'll see if we can compile this and if it works. So I compiled the program, updated it here, and see what does it do. 1, 2, 3, 4, 6, 7, 8, 9, 14. Well, it's behaving better. 15, 16, but sometimes it counts like twice, or sometimes it counts even when I release the button. 3, 4, 5, 7. See what is it doing? It's slightly better, but it's still not perfect. It counts the counts, but sometimes it counts extra. So what's the problem? Well, with buttons, we have something which is called bounces. Right. So what happens when you look at the signal that comes out of the button? So when you press it, it doesn't go down nice like this, right? It goes like that initially, but then because of it's just a mechanical device, button, just two pieces of metal smashing each other, so it will bounce several times, right? So when you press the button, it will go down, and then it will go up, down, up, down, up, down, up, and then it will stabilize to 0, right? So what might happen that my program see all of these individual edges, right? Here, here, there, there, as extra button presses that it can count, right? So in order to get rid of those, we have to do something called the bouncing. So what do is that we take only the first one, and then for a certain amount of time we just ignore everything in here, right? And here from now on we are waiting for another event. So how to improve our system so it does the button debouncing? I can take my my diagram from last time again, copy it here, and try to improve it so it does the button debouncing. So I said that when I press the button for the first time, then I want to wait for a little bit before I start to be sensitive again. So I basically want to add something like a timeout after I press the button. So I want the system to wait a little bit before it goes from the ready for key press, before it goes to the waiting for key press, for key release. So how can I implement this? Well, I can add another state that would be just waiting. Well, it would not be waiting, but it will be debouncing. So here, instead of this edge, I can break this edge by adding a new state. So I will have a state called debouncing key press. So I'll have state like that. I will put the edge back because the first edge does not change. The change going from the initial state to the waiting for debouncing is the same as we had before. So even these this condition here and this effect stays the same. Alright, but in the debounce, waiting for debounce key press, I want to, what do I want to do? I want to do waiting. I want to wait there. So I will create a new variable. I'll create a new variable that would hold the timeout for me. So when I go to this state, I would set up a variable timeout. I would set it, let's say, to 50 milliseconds, right? And then when I'm in this state, and the condition on this transition would be that 1 millisecond passed, and the timer and the timeout is bigger than 0. The effect would be that I would just decrease the timer by 1. So I would do minus minus timer, right? And I would have another transition here going outside of this state, and that would be if the timer is equal to 0, I would just go out. So I would have the condition here would be, well, sorry, not timer, I wanted to say timeout. Timeout is equal to 0, I would just go there and do nothing. So this state here, basically what it does, that when the system enters there, it has to wait 50 milliseconds and then it can continue. So this system implements waiting for us. I'll just rename this, it's not timers, timeout. Timer out. The same here. Time timeout. Right. Okay, so we did the bouncing on the key press. We have to, but the button bounces even when we release it, so we have to do the same thing on the button release. So I will just delete this edge, quickly add new state. There would be debouncing, key release, right. Into this state I would get from the waiting for key release. I would get out when the timeout passes, and I would do the same thing here. So if button released, so the condition on this one would be button was released, and the effect would be set the timer to 50 again. Sorry, not timer but timeout. Timeout to 50. I would go out when the timeout is equal to 0, and if the timeout is bigger than 0 and 1 millisecond passed, I would just decrease the timeout. Bigger than 0 and 1 millisecond passed, and the effect would be here, or the action would be to decrease the timeout. Right? It would be decrement the timeout by 1. So now we have the bouncing on the key press and the key release as well. So let's try to implement it and see if this improves our state machine. So I need two new states. So I would have a state debouncing key press, and I would have state debouncing release. Okay, I would, in my switch statement, I have to add two new cases for the two new states. So I would add both of them. State debouncing release. Okay. Alright, so now what do we have to add? So here, how do I have to update the ready for key press state? So when I press the button, I want the state to change into state debouncing press. I want to increase the timer, the counter, update the display, and set the timeout variable to 50 milliseconds. I have to define the variable. So orientate timeout. Just initialize it somehow in the beginning. Okay, so this would go to the bouncing press and set the timeout to 0. Here, if the timeout is bigger than 0, I would just decrease the timeout. And else means the timeout is 0, I would just go to the waiting for key release press. How to simulate the 1 millisecond delay? Well, the easiest thing in this case is to just add a delay millisecond here, so that the machine, our state machine, is executed with 1 millisecond steps. Approximately 1 millisecond frequency of execute. So it's my kilohertz frequency of execution of this loop. So now our state machine evaluates the states every millisecond. So if I on each evaluation decrease the timer by 1 and the timer was 50, it should be approximately 50 milliseconds until I get out of this state. So I am in state waiting for release. How do I have to change this state? So I would go not to the waiting for key press, but I would do debouncing of key release, and I would out the timeout set to 50 again. And in the debouncing for key release, it would be very similar. So I can copy the guts from for the other state, and just edit it. So timeout bigger than 0, decrease the timeout. That's okay. That's the same. Else, if the timeout is 0, so the timeout is done. So I want to go to being ready for new key press. So I would just change the destination state like that. And this, if I'm not mistaken, should be our code now ready to be tested. So I'll just try to compile. I made a mistake somewhere. Oh, I'm missing a semicolon after break. Shall we just copy? And I need the library for waiting, so I would go include AVR. Or it was not AVR but util delay. Try to build it now. Okay, so I have no idea what the problem is. I just cleaned the solution, compiled it again, and it works. So maybe I just forgot to save it. Alright, so now now I will test the program. So I am going to upload it. Okay, so I uploaded the new program, and now I'm testing press 1, press 2, 3, 4, 5, 6. I keep pressed and nothing happens. Release again. Every time it increases by 1, never does more. So now the system is doing what we wanted. So we had to wait for the key release, and we also had to debounce everything. So now the implementation is as we wanted it to be. Okay, so I showed how to design this system here. We draw the diagram, and then we converted it into C program. How did we do it? So first we set a variable that holds the state. Then based on this variable, we have different cases for each state we have in the program, and in these states, we just do all the conditions and all the effects and actions we have. We simulate the delay by running this entire loop once every millisecond. Okay, so now how we can improve it. So let's say that we want to change our program to do something more. We want it to count not only, we count two different kind of presses. So we want short presses and long presses. Okay, so we can start from this diagram we already have. I'll just copy it to a new page. Now we can extend this program so it can count long presses and short presses as well. So what do we have to change it here? So I want to distinguish if I press the button for less than 500 milliseconds or for more than 500 milliseconds, and increment the different counters based on the timing. So what can I do? So first, I am not going to increase the counter on the key press, but I will increase the counter on the key release. So whenever the button is released, I will increase the counter. And also I will update the display, because now the updating display there does not make much sense. So when the button is released here, I will increase the counter, and it would count my short pulses. Now, how to distinguish between different length of pulses? So I can have another state that would wait for the long pulse, right? So I'll have a state waiting for long release, right? So whenever I'm in this state and I release the button, so I would go into the debouncing state again, and now I would set the timeout. I will copy this because it will be very similar. So when the button is released from waiting for long key press, I would set the timeout to 50, I would increase the long counter, that's a new variable, long counter, and I would update the display again. So here at the beginning of the program I of course have to initialize the long counter to 0. These actions happen whenever I'm resetting my state machine. Okay, so that's how we get out. Now, how do we get in? So first we can have another timeout here that would count the long press delay. So you would set the timeout variable to 450 because we already have 50 seconds for the timeout here, and then we have another 450 milliseconds, giving us altogether 500 milliseconds for waiting for the long key press. And similarly as in the debouncing state, I would just decrease the timer here. So if the timeout, so every 1 millisecond, and timeout is bigger than 0, I would just decrease the timeout. So I would have minus timeout, and if the timeout is 0, I would I would go to the other state. Timeout is equal to 0. I would just transition to this state. So whenever I am in the ready for key press state, I am in the ready for key press, and I press the button. I am going to do debouncing. After 50 milliseconds debouncing, I would wait for release. Now, if the button was released in this state, I would increase the short key press counter. But if I keep it pressed and the timeout goes to 0, I would transition to the waiting for long key release. And if I release, then when I release in this state, I would increase the long counter. I would do the bouncing and go back to the ready for key press. So we have one more additional state and one more new variable. So let's go back to Atmel Studio and implement it and see how it performs. So I need to add one more state. So that's state waiting for release, and it would be long release. Okay, so that's my new state. I have to add this state into switch statement. What am I doing? Case thing for key release. And in this state, what happens in this state? So if the button is not pressed, if not the button pressed, I would just go to the debouncing state, set the variable, so from this state I want to go to the debouncing state and set the timeout and increase the long press timer, long press counter. How is this? So it would be ++ long press counter, and I also want to update the display, and I want to update the press counter and long press counter. So now I have to define my new variables. So I would have press counter 0, long press counter is equal to 0 initial. I need to update my display function. And I want to print the other variable as well, so I will have count short and I will have count long. I hope it can make it on the display. So how many characters do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 15, 15 characters, so I should change like that. Now it definitely fits on the display, and I want a long press counter. So that's my update display function is updated. I have new variable here, and now check all the states. So when I am ready for key press and the button is pressed, I want to go to the debouncing. I don't want to increase and I don't want to show it, because I want to do this whenever I'm releasing it. So I will move this to the releasing state. So in the ready for key press state, I'm only waiting for the button press, and I transition into the bouncing. Into the bouncing state, I'm just waiting for the timeout to go to 0, and then I transition to waiting for release state. When I'm in the waiting for release state, well, I transition to waiting for release state, and I set the timeout to 450 milliseconds. When I am waiting for release, if the button is pressed, I would go to debouncing, I would set the timer, increase the count and update the display. Or if the timeout is bigger than 0, I would just decrease the timeout. Else I would, and when the timeout is equal to 0, I would just go to the waiting for long key press. So state is equal to waiting for long key release. Oh, sorry, waiting for key release, and that's it. So when I go to the waiting for long key release and the button is not pressed, I would increase the long press counter, set the timeout, go to the debouncing, and update the display. And if I am in the debouncing, I would just decrease the timeout. When it's 0, I would go to the waiting for key press. So this code looks good. Let's try to build it and see if we have some errors. So update display needs the new variable, so let's add it there, and it's here, and that's it. Oh, and this warning tells us that large integer implicitly truncated to unsigned type. That means that 450 is too big and it wouldn't fit in the timeout variable. So we need, of course, timeout is just 8 bits, so we need to increase the size so it can go all the way up to 450. I will try to build it again. Let's see if we have some errors. No, now it looks good. So now I will go and program the microcontroller again and see. I uploaded the new program in microcontroller. Let's see what it does. So when I press it shortly, it increases just the short timer, and if I press it for longer time, it's increasing the long timer, the long variable. So now I can decide which one I want to increase by pressing it longer than 500 milliseconds. Cool. Yeah, so this program works perfectly. We designed it, and we designed it using state machines. Yeah, so this program works perfectly. We designed it, and we designed it using state machines. Then we implemented the state machines basically just a big switch state. And this program worked on a first compilation and first upload. I did not have to do any debugging, and this was just because I used state machines to design and think about my program in advance, and I did not have to do any difficult debugging or just guessing based on my code and trying to find errors, because my design and my plan, this state machine was designed well from the beginning. Then I just used simple rules. I showed you how I converted this diagram into C code. It was done by saving the state in a variable, then having a while loop that goes in iterations around and executes code based on those functions. And in those functions I have one if statement representing every transition, and that's it. So let's say waiting for key release state. Here I have 3 statements, so I should be able to find this. No, it was, what was it? I should be able to find this, so it's waiting for release. So if button is pressed, I go to state release. There's one transition. I have self transitions just decreasing the timeout, and I have another and then I have transition to going to the long state. And we should be able to see these three transitions in the diagram as well. So here is the self transitions. Then I have one transition going to the debouncing and another one going to the waiting for long key press. So yes, that's it. That's all I wanted to show about state diagrams. I suggest to use it whenever you can, because it's very avoiding problems is easy, just for the reason that you can use the diagram to plan and to design the code, to design the program in advance, and it's easier to design it than directly writing the code. So thank you for